The functional elements of a solid waste management system, SWM, are the different stages or steps involved in the management of solid waste, from the point of generation to the point of final disposal. The 6 essential functional elements of SWM are: waste generation. This involves the identification of materials as no longer being of value and either throwing them away or gathering them for disposal. On-site handling and storage. This involves the proper containment and temporary storage of waste at the point of generation. This can include activities such as waste segregation, waste minimization, and the use of appropriate containers or bins. Collection. This involves the gathering of solid waste and the hauling of waste after collection to the location where the collection vehicle is emptied. Transfer and transport. This involves the transfer of waste from smaller collection vehicles to larger vehicles at transfer stations, and the subsequent transport of the waste to disposal sites. Material and resource recovery. This involves the separation and recovery of valuable materials from the waste stream. This can include recycling, composting, and energy recovery. Disposal. This involves the final disposal of waste that cannot be recycled or composted. This can include landfilling, incineration, or other disposal methods. The 6 functional elements of SWM are interconnected, and all are important for a safe and effective SWM system. For example, if waste is not properly handled and stored at the point of generation, it can become a nuisance and a health hazard. If waste is not collected and transported efficiently, it can accumulate and create public health and environmental problems. And if waste is not properly disposed of, it can pollute the air, water, and soil. An effective SWM system is essential for protecting public health and the environment. By implementing effective SWM practices, we can reduce the amount of waste that is sent to landfills, improve recycling rates, and conserve natural resources. Solid wastes can be classified based on their source and type. Source-based classification. Municipal solid waste, MSW. MSW is generated from residential, commercial, and institutional sources. It includes food waste, paper products, plastic, metal, glass, and other materials. Industrial waste. Industrial waste is generated from industrial and manufacturing activities. It can include a wide variety of materials, depending on the type of industry. Examples include chemicals, metals, plastics, and hazardous waste. Agricultural waste. Agricultural waste is generated from farming and agricultural activities. It can include crop residues, manure, and animal carcasses. Construction and demolition waste. Construction and demolition waste is generated from construction and demolition projects. It can include concrete, wood, metal, and other materials. Hazardous waste. Hazardous waste is any waste that poses a threat to human health or the environment. It can include toxic, flammable, corrosive, and reactive materials. Type-based classification. Biodegradable waste. Biodegradable waste is waste that can be broken down by biological organisms, such as bacteria and fungi. This includes food waste, yard waste, and paper products. Non-biodegradable waste. Non-biodegradable waste is waste that cannot be broken down by biological organisms. This includes plastic, metal, and glass. Hazardous waste. Hazardous waste is any waste that poses a threat to human health or the environment. This includes toxic, flammable, corrosive, and reactive materials. It is important to note that some wastes may fall into multiple categories. For example, food waste is both biodegradable and municipal solid waste. By understanding the different types of solid waste and their sources, we can develop effective waste management strategies. For example, biodegradable waste can be composted, while non-biodegradable waste can be recycled or landfilled. Hazardous waste must be disposed of in a special way to protect human health and the environment.